Hi everyone, once again I welcome all of you in this SSK Study channel. So today we will going to discuss the next topic of the unit number 2, that is the types of load and related deformation. In last lecture we have discussed the various types of loading conditions which is occurred on the body for the strength of metal subject that we have to discuss. Now today we are going to discuss the different kind of related deformation with respect to that loading condition. Okay, in case of a direct load we already discussed there are the two types of direct load, that is direct tensile and the direct compressive. So due to the direct tensile loading there will be a tension in the body, or the related deformation will be the tension type, and due to the direct compressive type loading there will be a related deformation compression. Next, that is eccentric loading. Due to the eccentric load, the related deformation will be a flexure. What actually the flexure is? The bending action of the beam, it is generally called as the flexure. Next, due to the shear load, the related deformation will be the shear, and due to the torsional load, the related deformation will be the torque. This is the simple topic that given in the syllabus point of view. Next, that is very important concept for the strength of metal subject, that is the stress. Before going to understand the stress concept, let us first of all go through the very basic concept, that is the internal resisting force. Let us consider one object which is placed over here, which is placed over a certain flooring. In that case, when we are applying any external force on the object, let's suppose this is the external force which is acting on object, and that object it is placed over the floor or any other supported material, or it is supported by at the ground. Now when you are applying any external force, that body will offers equal and opposite reaction to that force. Okay, so that reaction or that internal force, in that resistance offered by an internal material to the external applied force, that force set up in the body, it is nothing but called as the internal resisting force. Now let us consider the stress definition. Now that internal resistance force per unit cross sectional area offered by the body to the external force applied, it is generally termed as the stress. So once again I will repeat the definition, or in simple forms we can call it as an internal resistance force acting per unit cross sectional area to the external applied force, it is generally termed as the stress. Now after understanding the concept of stress, let's go through the formula and its denotation and its unit. Next, the formula. What will be the formula for the stress? It is simple: internal resisting force per unit cross sectional area. So what is the denotation of the stress? It is generally denoted by a letter, that is sigma. Okay, but this particular sigma for the varying stress it may be different. Okay, so for the shear stress we will denote it by the tau. For the bending stress we will denote it by the sigma suffix v. That will be we will see that topic at that point of instance. So generally that internal resisting force will simply denote it by the F, and the unit cross sectional area we will denote it by the A. Now let's see the unit for this particular concept. So in general it is denoted by Newton per meter square, because we know that the unit of force or the load it is Newton, and the normal area of cross section we will denote it by the meter per meter square. So Newton per meter square, it is also called it as a Pascal, or it is called as 1 Pascal. Simple, I have given over here 1 Newton per meter square is equal to 1 Pascal. But in most of the cases when we have to find out the stress, it is that area of cross section is very smaller. Okay, it is given in terms of the mm, 1 mm square, 2 mm square, 6 mm square, like that way. So we have to calculate the stress in terms of the Newton per mm square. In most of the case, in most of the numerical, we have to calculate the stress in terms of Newton per mm square. So this is very important unit for the subject point of view, that is 1 Newton per mm square is equal to 1 megapascal. So what will be the 1 megapascal? 1 megapascal is equal to 10 raised to the power 6 Pascal, and 1 kilopascal is equal to 10 raised to the power 3 Pascal. Okay, this particular unit conversion, that is 1 Newton per meter per mm square is equal to 1 MPa. How it is obtained, that I have already mentioned in my notes. You can go through that. That is 1 Newton per mm square is equal to 1 megapascal. Most of the time we will go through this unit only in numericals. Then the various types of stresses. Again, these types of stresses are depend on the types of loading on the body. What kind of loading which is acting on the body, on the basis of that we will categorize the different types of stresses. So if the body it is subjected to the direct load, then the stress induced in the body it is called as the direct stress. Then the stress induced in the body it is called as the direct stress. Here are okay, if the body is subjected to the direct loading condition, the stress induced in the body it is called as the direct stress. Again we know that the direct loading condition it is of the two types, that is direct tensile and the direct compressive. Therefore that stress it is again, if the direct tensile, if the loading condition will be the direct tensile, then the stress induced in the body will be the direct tensile stress. And if the loading condition will be the direct compressive type, then the stress induced in the body will be the direct compressive stress. Next, let's see the eccentric loading condition. I have already discussed that due to the eccentric loading condition, that bending stress it is generated in the body or occurred in the body. And next type, that is due to the shear loading condition, that stress is generated in the body will be the shear stress. One by one we have already bending stress. We have to discuss that bending stress in the unit number 6, that we have separately a separate topic it is given to us. And this particular tensile stress and compressive stress we have to study it in unit number 2 and unit number 3. And at the same time simultaneously the punching shear and on numerical on that we have to discuss in unit 2 and unit 3. So this is overall concept of the types, or overall the revision of the types of stresses. Now let us see the next concept, that is the strain. This is also very important concept as far as this subject is concerned. So what actually the strain is, we will go through the first of all the definition. It is defined as the ratio of amount of deformation in the direction of applied force. This is very important term. Most of the time the student does not know that what actually the loading condition in which the force get acts. So the direction of load it is very important, direction of applied force is very important in the strain concept. So it is very simply it is defined as the change in dimension to its original dimension. It is generally defined as the ratio of change in dimension to its original dimension. I have just shown one rod over here, and it is subjected to a direct tensile load. Okay, next we will see the various different types of strain, that is the types of strain. In this, again the types of strain we have to discuss, that is 4 different types of strain that we have to discuss in this topic, that is linear or longitudinal stress, then lateral strain, then shear strain, and then volumetric strain. We will discuss these particular types of strain one by one. So let's see first of all the linear or longitudinal strain. Once again I will clearly mention you student, this type of strain again it is depend on the dimension which may get vary. Okay, due to the application of load, which type of dimension may get vary. If the change in length get vary, then the perpendicular dimension may get vary, then the different type of strain. So let's see one by one. So first concept is the linear or the longitudinal strain. Let's see definition. Whenever the bar is subjected to an axial load, there will be an increase in the length of the bar along the direction of the loading. Therefore, longitudinal strain is defined as the ratio of increase in the length of the bar to the direction of applied load to that of the original length. In simple, longitudinal or direct strain or linear strain, it is defined as the change in dimension in the direction of force. Because this particular sentence that I have spoken over here, it is not mentioned in the definition. What I am going to tell you, that the change in dimension, if the change in dimension is in the direction of force, then it will be linear type, or then it will be a longitudinal type. If the change in dimension is in the direction of force, okay, so that change in dimension is in the direction of force towards the original dimension, it is called as the linear strain. So here generally that linear strain, it is denoted by an epsilon. In most of the reference book, if you observe, then it is denoted by an epsilon, but for our reference, for further numerical, we will denote it by the small e. We will denote it by the small e. Small e, that is the longitudinal strain. Then delta L is the increase in the length, and small l is the gauge or the original length. We will call in terms of when we are going to perform the practicals on the universal testing machine, then it is very important, that is gauge length and all these things. Okay, so just consider over here, that is L is the original length. So that linear strain will be what? Delta L upon L. So change in length upon original length. So here I have shown over here, when we are pulling a certain object, when we are pulling a certain object, then there will be a change in length. Here I have shown with the help of this particular graphics, when we are going to pull certain object, then there will be a change in length, but at the same time what will happen, the diameter of that rod or the particular thickness of that material goes on decreasing. So due to that condition, another strain that we have to discuss. Okay, at the bottommost portion I have shown one image over here, that is change in length for change in length due to the tensile load and the change in length due to the compressive load. So this is the concept of linear or longitudinal strain. Next we will discuss, that is lateral strain. What actually the lateral strain is. Okay, now in this case, when you are applying a load in any direction, then at the same time there may be a variation in the dimension to its perpendicular to the direction of force. Okay, let's suppose this is the direction of application of the force or the line of action of force, but there may be a vary in the dimension which is perpendicular to the direction of force. Now in that case length will be increased, but that length it is parallel to the line of action of force, but diameter it is perpendicular to the line of action of force. So in that case, this particular diameter, it is called as the lateral dimension. It is called as the it is called as the lateral dimension, but this length it is called as the linear dimension. So if this lateral dimension get changes, that lateral change in lateral dimensions per unit original lateral dimension, then it is called as the lateral strain. So this is the important concept. Once again, what I have told here, that is change in lateral dimensions per unit original lateral dimension. Once again, we will go through the definition. Whenever the bar it is subjected to the axial load, there will be a decrease in the dimension of the bar in the perpendicular directions of loading. Therefore, the lateral strain is defined as the ratio of decrease in the length of the bar in the perpendicular direction of applied load to that of the original length. So in this case, we will denote it by the change in diameter upon original diameter. So symbol, once again it is denoted by E, but in most of the reference book or the in our notes we will generally denote it by the E suffix L. E suffix L. Next, where E is the lateral strain, where DD or the D suffix D is the change in the depth or the change in original depth, then change in breadth, and gauge in original breadth width. That is the very simple point that we already discussed in our notes. You can go through notes also. Next, what actually the difference between the linear strain and lateral strain? Most of the students have confused about this. Linear strain is what is linear strain and what is lateral strain. Okay, so change in dimension occurs in the direction of applied load, it is called as the linear strain. Once again, I will tell you that the change in dimensions occurs in the direction of applied load, then it is called as linear strain, and it is denoted by E is equal to delta L upon L. But now the change in dimension occurs in the perpendicular to the line of action of applied load, then it is called as the lateral strain. Then it is called as lateral strain. In simple way, that in lateral strain, let us suppose that I will show with the help of one diagram over here. Let us study. We'll go through it. Pointer over here, focus pointer. Let us see that particular concept of the lateral strain, what actually the lateral strain is and how it is we will use it next. Okay, now let's suppose this is the particular bar. If you are applying the load in this direction, now length is in the direction of force, so it is called as the linear dimension, but the diameter of this rod, it is perpendicular to the direction of force, so it is called as the lateral dimension. It is called as the lateral dimension because what, it is perpendicular. If you increase the load, the diameter will goes on decreasing and the length will be the increases. That is the simple concept that I have shown over here. Okay, now once again we will back to the PPT. So that is the difference. So that change in lateral dimensions to its original dimensions. Now the lateral dimensions will be the diameter, lateral dimensions will be the thickness, lateral dimensions will be your breadth also. So it depends on the application of load. Next we will see the concept that is the shear strain. Again it is due to the shear loading conditions. When we are going to apply a tangential or parallel to the force, then that particular face only moves. In that case, that change in dimension over a fixed perpendicular dimensions, change in dimensions toward the fixed perpendicular dimension, it is termed as the shear strain. So it is the ratio of change in deformation to the original length of perpendicular to the axis of the member due to the shear stress. It is termed as the shear strain, and it is generally denoted by an letter gamma, that is tan gamma is equal to A by B, where A is the change in deformation and B is its perpendicular length. Let's see the next concept, that is volumetric strain. That is volumetric strain. The volumetric strain is the unit change in volume per unit volume. Unit change in volume, that is change in volume divided by its original volume. It is very simple and it is defined as the change in volume per unit volume. This is very important concept when we will go through the uniaxial stress system and biaxial stress system. At that time it is very important to uh, formulate the volumetric strain and to find out the volumetric strain. In simple, it is simply denoted by an symbol, that is E suffix V. So once again I will revise the formula for it, that is volumetric strain will be the change in volume upon original volume. So this is all about the today's concept. In upcoming lecture we will discuss the stress strain diagram for the ductile and brittle material. Thank you for watching this video.